All right, here we go. We're section 10.2. Use combinations and the binomial theorem. So a combination, yesterday we looked at permutations, and a combination order is not important. And it basically you just say it as n choose r. For example, when you're dealing a deck of cards into 5 card hands, that it doesn't really matter how they go out. That's a combination there. Taking n items and grouping r of them at a time. These are some key words you're going to want to look for that might help you identify when it's a combination or a permutation. If you're working in a pair, a group, or committee, you know that you're going to be dealing with combination. All right, take just a second to do the warm-up. All right, here's the answers for the warm-up. Most of it I probably would just use my calculator for, and hopefully it all went out well. If it didn't, just ask me about it tomorrow. Okay, let's start working with combinations. One thing you want to keep in mind when you're working with combinations is if you see an AND in the problem, the AND events, you're going to end up multiplying the different combinations together. If you see an OR in the events, it kind of is a clue to tell you that you're going to add the different combinations together. Right? So here, combinations of an objects take an R at a time. This is just kind of the general formula. Like for example, if you have 10 objects and you need to choose 4 of them, it'd be 10 choose 4, and it'd be 10 factorial over 10 minus 4, which would be 6 factorial, times 4 factorial. And we'll just practice it a little bit. All right, parents have 10 books that they can read to their children this week. 5 of the books are nonfiction, and we have nonfiction, and 5 of the books are fiction. If the order in which they read the books, right there, order is not important, that tells you right there it's a combination, how many different sets of 4 books can they choose from? Well, you have 10 total, and you want to choose sets of 4. And if I just kind of base it off what it says here, remember this is my n and this is my r, so I'm going to have 10 factorial divided by n minus r factorial, which is 6 factorial, times r factorial, which is 4 factorial. You could write this all out if you want to, or again you can just go to your calculator and you can, it's in the same spot as permutation except it's going to be the one right above it. So if you go to probability, you can see there's n choose r right there. So I would do 10 and then go to math, over to probability, down to 3, 10 choose 4, and I get 210. Again, you're welcome to do it by hand if you want, but I just feel like that's a lot of work. It would look something like this. This is what you would end up with, and you would end up crossing off all the 4, 3, 2, 1, and then the 6 and the 5, so really you have 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1. All right, let's keep going because we have a lot to cover today. And how many groups, there's one of those key words. Groups is going to tell you need to use combinations of 4 books, or all the books either nonfiction, or, there's that key word which tells me I'm going to have to work with more than one combination and I'm going to add them. There's 5 nonfiction and 5 fiction, remember. So, and how many groups of 4 books are all the books either nonfiction or fiction? Well, first of all, for the fiction, I have 5 to choose from, and I want to choose 4. And then I got to do the nonfiction one, which I also have 5 to choose from, and I need to choose 4. 5 choose 4, if you go to the calculator, there's 5 ways to do that. 5 choose 4, there's 5 ways to do that. So there's actually 10 ways to choose these books, 4 fiction or 4 nonfiction. Okay, we're going to practice a couple more problems like this. The student senate consists of 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. You might have to keep in mind that there's 18 total. We may not need that. Let's see what they're asking us. How many committees, right there it's a committee, we need to use combinations, of exactly 2 seniors. Oh look, there's that and word. When it's and, we multiply our combination choices. And 2 juniors be chosen. So the first thing I have to figure out is if I have 6 seniors and I choose 2. Okay, that's the senior committee. Then I got to multiply it because it's an and by the junior committee. I have 5 juniors and I got to choose 2. And when I do that, I get 6 choose 2 as 15, 5 choose 2 as 10, There's 150 different ways to choose these committees. Some other wording you might see is how many different committees of at most 4 students can be chosen. Okay, well, at most means 4 or less in each committee. So this or tells me I've got to go through and add all the different possible combinations. So this is where we're going to use the 18 total. If I figure out the committee where you can choose 4 students for the committee, the first one would be 18, choose 4. Then I also have to consider the committees where there's only 3 people. So 18, choose 3, plus 18, choose 2, plus 18, choose 1. When I add up all those different possibilities, I get 4,047. And again, all I'm doing is just putting this on the calculator. All right, you're going to toss 10 different coins. How many different ways will at least, there's at least 4 of the coins show heads. That means you could have 4 coins show head, or you're curious to know if there's 5 or 6 that show heads. So 4 or more. That means you have to consider all the different combinations of the different numbers that show heads, and you're going to add them together. So again, if I have 10 coins and I want to choose 4 of them as showing heads, how many ways can that happen? I'm going to add to that the 10 coins and 5 of them showing heads. How many ways could that happen? And so on. We go all the way up to 10. 10 choose 6 with heads, 10 choose 7 with heads, 10 choose 8 with heads, 10 choose 9, plus 10 choose 10. And if you think about it, as this number goes up, the chance of getting 7 heads is a lot less than the chance of getting 4, so this number would be a lot smaller. But if you add them all up, there's 848 different combinations. Okay, you may or may not have seen Pascal's triangle. I'm not sure, but there's all sorts of fantastic things that we can see in Pascal's triangles. One of the big reasons we use Pascal triangles is when we're working with combinations. So we have to consider the rows of the triangle, and there's all sorts of magical things that occur here, but for the combinations, I'm going to show you how we use it for that. In the 0 row, you can think of it as 0 choose 0. There's one way that can happen. In the first row, 1 choose 0. There's one way that can happen. 1 choose 1. There's one way that can happen. The second row, and so on. It keeps going like that. 2 choose 0. There's one way that can happen. 2 choose 1. There's 2 ways. So again, we use these numbers to help us determine the number of combinations. The cool thing about Pascal's triangle, if you haven't worked with it before, is if you notice when you add 1 and 2, you're going to get 3. 2 and 1, you get 3. So that's kind of where those numbers come from. And 1 is always on the outside here, and 1's always on the outside here. You don't really need to know that for now. But what I am going to do is I'm going to expand this to a 6th and a 7th row because we're going to need that. So I'm going to write a 1, and then I know the next number is 1 plus 5, which is 6. And then 15, 10 plus 10 is 20, and then 15, and then 6, and then 1. This is where n equals 6. Then I'm going to do n equals 7. I'm going to put a 1 out here, and then 1 plus 6 is 7, 21, 35, I get 35, get another 21, I get 7, and then I got to end it with a 1. All right. So here's how we use this. From a collection of 7 baseball caps, you want to trade 3 of them. Use Pascal's triangle to find the number of combinations of 3 caps that can be traded. So I have 7 choose 3. Well, if I look at the pattern here and line it up with my 7th row, because this 7 means you're using the 7th row, I got to consider, okay, so here this means that I have 7 choose 0 is 1, 7 choose 1 is 7, 7 choose 2 is 21. Oh look, 7 choose 3 is 35. And that's how you can use Pascal's triangle. Of course, you could just throw it on the calculator as well. It's just kind of a nifty little trick with this triangle. Okay, probably the biggest thing that you're going to learn in this section is using the binomial theorem to expand binomials. So let's just go ahead and do it. And what I did was I wrote out the steps for what you're going to do. It's like if you have x plus y cubed and you need to, say, FOIL it out. Okay, it's very easy to use this theorem to do that. It gets kind of messy when you have to start to FOIL. So here's the steps that you're going to do. Exponent tells you which row of Pascal's triangle to use as coefficients. Okay, you're going to write the first term from left to right with decreasing exponents, write the second term from right to left with decreasing exponents, and simplify each column. And I'm going to walk you through it. First of all, I wanted to point out that there's a copy of this on the back of your notes, Pascal's triangles. These numbers are actually going to correspond to the coefficients that you're going to find when you expand a binomial. So we're going to use this too. All right. So what I want you to do here, we have to expand x plus y to the 5th power. The first thing I want you to do is the exponent tells you which row of Pascal's triangle to use as coefficients. So this is a 5. I'm going to go here and I'm going to look at row 5. These are going to be my coefficients, 1, 5, 10, 10, 5, and 1. So I'm going to list those right here with just a little bit of space in between. Okay? Now, the next thing I'm going to do is I'm going to draw just a little line here just to keep these columns organized. Write the first term from left to right with decreasing exponents. So here this is x, and the first one it's going to be is x to the 5th. And then I'm going to go down x to the 4th, x to the 3rd, x squared, x to the 1, and x to the 0 is just 1. Don't forget that. Then it says write the second term from right to left with decreasing exponents. Be careful, right to left. That means you start over here in this column with y to the 5th, y to the 4th, y to the 3rd, 2nd, 1, and then remember y to the 0 is just 1. So I'm just going to put that there. Then I'm going to draw a line down here. Okay, and then what you do is you go down and you simplify each column. So here I got to consider these as the numbers. 1 times 1 is 1 times x to the 5th. So my first term is going to be x to the 5th plus. And then I have 5 times x to the 4th times y. So my second term is 5x to the 4th y. Then I have 10 times x to the 3rd times y squared. Oh my goodness, it's starting to shape up to a polynomial. This is 10x squared y third plus 5x y to the 4th plus y to the 5th. And would you look at that? That is your answer. You have expanded this and it would equal that. Pretty nifty, don't you think? Okay, let's try another one. This is a little bit more complicated, but it's not bad. We have 3x minus 2 to the 4th. The 4th tells me I'm going to use the 4th row, and these are going to be my coefficients, 1, 4, 6, 4, and 1. So I'm going to write that down. 1, 4, 6, 4, and 1. And I'm going to just draw some columns here to help me stay organized. Okay, that's the step 1. And then step 2 says, write the first term from left to right with decreasing exponents. Now my first term here is 3x. So I need to put 3x in parentheses, and that's going to be to the 4th, and then 3x to the 3rd, 3x squared, 3x to the 1st, and 3x to the 0 is just 1. And then I got to do my second term, which is negative 2, starting over here at negative 2 to the 4th, negative 2 to the 3rd. Be sure and put that in parentheses because it's a negative. Negative 2 squared, negative 2 to the 1st, and then negative 2 to the 0 is just 1. Now I got to simplify all my columns, so I'm going to work my way down. This is a little trickier because we have a 3 here. So we have 1 and 1, which is fine, and 3 to the 4th, which is 81. Remember, you have to distribute that 4 through both of those. So it's 81x to the 4th. Okay? Then, up here, it gets a little bit more complicated. We have to distribute this 3. So we have 4 times 27, because 3 to the third is 27, times negative 2. So 4 times 27 times negative 2 would be negative 216, and I have x to the third. Then here we have 6, then we have to distribute that, times 9, times negative 2 to the fourth. I'm sorry, this is supposed to be a 2. Did you catch me on that? So here we have 6 times 9 times 4, which is going to be a positive 216x squared. Here we have, distributing this exponent, we have 4 times 3 times negative 8, which is going to be a negative 96, and it's x to the 1. And then here, it's 1 and 1. 1 times 1 is 1. Negative 2 to the fourth is a positive 16. And there, we have expanded it. It's just lovely, isn't it? All right, this last one here. This is one different way that you're going to have to do it. It says find the coefficient of x to the third, y to the fourth in 2x minus y to the seventh. Now remember, there's a couple ways you're going to do this. I'm going to show you 2 different ways. Okay. The first way is if you just remember that this 7 tells you you're going to be using row 7. So I'm going to just kind of write down what I see in row 7 as coefficients. 1, 7, 21, 35, 35, 21, 7, and 1. And I know that I need x to the third here. And if you remember our method up here, we started out with the highest exponent for my x, so I'm just going to kind of go here. So this first position would be 2x to the 7, 2x to the 6, 2x to the 5th, 2x to the 4th. Oh, look. Here is where I hit the third. So that tells me that I'm going to be using 35, and this is also where y will be to the fourth. So this is kind of like the column I have to simplify like we just did up here. So it's going to be 35 times 2 to the third, which is 8, and that's it. 35 times 8 is 280, x to the third, y to the fourth. So there's just kind of one way to think about it. Now, the other way we can think about it is using this right here. It tells us n choose r times a to the n minus r times b to the r. We can use that to help us expand. So I'm going to write that down here. A plus b to the n is equal to n choose r times a to the n minus r times b to the r. Now here's what they want me to expand, so I'm going to write it right underneath here. 2x minus y, to the 7 equals, I don't know what this is right now. I'm going to leave that blank. But I know what I'm looking for is x to the 3 and y to the 4. Oh. Now what I need to find out is I need to know n and I need to know r. I know right here that n is 7. And if I look at this position right here, I know that the 3, the n minus r here, is equal to 3, which tells me that my r is 4. Cool. Now I can just set it up using this little formula and I can find out what the coefficient is. I have the n and the r. So I have 7 choose 4 times my little lower, the first part of my binomial was 2x to the third times negative y to the fourth. And all I have to do is simplify that. So it equals 7 choose 4. I'm not sure what that is. I can't remember what that is right now. It's 35, sorry. Times, distribute that, 8x cubed. And then this is going to be just positive y to the fourth. So I could do 35 times 8 is 280x cubed y to the fourth. And there I found my answer. So there's 2 ways you can look at this. And that is it. Isn't that fun?